Assalamu alaikum, dear students. Today we'll discuss about your Heikel. So let's start from the beginning, and we'll discuss few questions that are probably very important from the exam point of view. Let's start from one by one. So this is the first type of question. So we'll just quickly review and how to study. So I hope you have your Heikel with you. So the first here you have to focus on what is your center of mass and how to find out the center of mass for different types of object. So these are few specific questions here given. So let's discuss them one by one. So here, based on the definition of center of mass, which a point of the following is the center of mass of the solid metallic sphere? So where is the center of mass of the solid metallic sphere? So it is at the geometric center of the object. So the next one, this is your if the center of mass, the question is here, if the center of mass is here, so which of these objects M1 and M2, which one is greater in mass? So definitely the center of mass will tend to go towards the object where the center of mass is your more. So that means M1 is greater than your M2. Next question, this is your how to calculate the center of mass for this object. So this is center of mass. What is the formula? Center of mass formula is your, if you try to recall, this is M1. So if you remember it, so I think it was given like this. So XCM, so M1 X1 plus M2 X2 divided by your M1 plus M2. This is sum of their masses. So here two masses are there and their distances are also given. Make sure just try to find out one object at the center of origin. So it will have a lot of, it will become easy for you to solve the question at that time. Next, again, they have given another one question where you have to calculate the center of mass. Now, remember, sometimes they can ask you the opposite way. The center of mass given and you have to calculate the coordinate. If you have calculator, you can put it directly to do the reverse way. Next one, the difference between polar coordinate and your Cartesian coordinate. So polar coordinate is your r theta, Cartesian is your xy. If you just put them into the right formula, it is very clear one. So x is equal to r cosine theta, y is equal to r sine theta. So x square plus y square, that is equal to r square sine square theta plus r square cosine square theta. So that basically is your r square. So x square plus y square, this is equal to 1. So x square plus y square is equal to r square. And if you just take square root, so then it will become your polar coordinate. And remember, students, we in physics, we calculate the angle in radian, not in degree. So if your calculator is giving, it's given already radian, so make sure you change it to degree. This is your 37 degree, which is your 0.64 radian. So how to convert this one? I will just revise it quickly. So 360 degree is equal to 2 pi radian. So 1 degree equals 2 pi divided by 360, which is pi by 180. So 37 degree is equal to, so pi by 180 multiply 37. So you will get your 0.64 radian. Next question, this is your, so technically they have given what x and y given, you have to calculate r and theta. You can see meter and radian. So the solution is given. So r is equal to x square plus y square and theta is equal to tan inverse y by x. So which will give you 53 degree. Make sure to convert it into radian. How to convert? So pi by 180 multiply 53 degree. Next, r theta is given. How to calculate? Sorry. Again, xy is given. How to calculate r theta? Same way. Next one. This is your, again, the same thing. This is from your graph. So this is 5 is your x coordinate, 6 is your y coordinate. And just apply and then you will get your desired answer. Next one, the x and y coordinate changes, but the radius remains the same. So here you can see when you revolve something like this, one heavy object tied to the end of the string. So at that moment, which of the following statement is true? Here you can see the x and y coordinate changes, but the radius remains the same. How do you know that? So let's say this is the initial position 1. So its x coordinate this and y coordinate is your 0. Now if the object is here now, you can see the y coordinate is there, but the x coordinate is 0. So this is how the x and y coordinate is changing, but the radius is constant. Next one, this is r theta is given. Calculate the a to b. So s is equal to r theta. So r is given to you, theta is given to you. Then you just multiply, you will get your answer. Next question. A yo-yo rests on a frictionless surface as shown, which when a force F is applied to the string, what will happen to the yo-yo? So when you apply to the force here, so it moves to the left and rotate clockwise. So it's your clockwise rotation. So it will rotate like this. This is clockwise and this will be anti-clockwise. Now the next question. This is once again the same thing. It is given in another way. So here, this chart you have to remember, make sure this is omega is equal to theta by t. So its velocity is it's same like your displacement over time. Similarly here, your angular velocity omega is equal to delta theta by delta t. It's not this t, it's small t, or delta t also you can say. F is equal to 1 divided by t, and linear speed v is equal to omega r. It shows that the v and r, they are directly proportional. So v, so when the r is more, so the linear velocity is also more. Make sure if it is rotating in a circular path with constant omega, so velocity, linear velocity changes with respect to your radius. Next question here, they have given revolution. It is given. So one revolution means how many radians? It's 2 pi radian. So 7.7 revolution means 7.5 multiply 2 pi equals 47.1 radian. Similarly, they have given different multiple examples, same one. So make sure you just follow the right formula, then it will be easier for you to find out the answer. Next question that is given, calculate your angular velocity when your displacement is your given. Next, so how to calculate this one? So just you take one time, so s is equal to r theta. So ds by dt, take one time derivative. So d theta by dt is omega. That means if you take the derivative of s, then you will calculate easily omega. How? So ds by dt. So I hope you remember, multiply the power and decrease the power by 1, and this is 0. So 10t. So 10t is equal to r omega. Omega is equal to divide this answer by r. So this is your right answer. Next question. A flywheel is given. So technically it is the same one. So theta is given. What you have to calculate? Omega. Theta is given. Calculate omega. How to do it? So just d theta by dt. And you will get your omega. And from this one, if you are supposed to calculate alpha, so what you have to do, take one more time derivative of omega, then you will get alpha. Because this is a number, so its alpha is equal to 0. That means this is omega is constant. So when omega is constant, so angular acceleration is equal to 0. Next. So these are few examples are solved, and here you have to use 5 equations of motion. Technically, your omega is equal to omega 0 plus alpha t, theta equals theta 0 plus omega 0 t plus half alpha t square, and v is equal to r omega. So these are your combination of all those different types of formulas or equations of motions. Next one. So here they have worked out few examples. So I will scroll slowly so that you can just watch it out. I will share this file with you later on. So make sure you solve each and every one without seeing the answers. Next one. This is very interesting question. Your centripetal acceleration concept. So centripetal acceleration is the acceleration responsible for the circular motion, which is equal to your v square by r or v omega or omega square r. So this is your centripetal acceleration. If you have to calculate your centripetal force, just you multiply m with AC. That means centripetal force has three different forms: mv square by r, or mv omega, or your m omega square r. So here also the same way you have to calculate your omega. Next, this is also very important question. What does x represent in the given equation? So omega square equals omega 0 square to alpha delta theta. So here x is your alpha, or they can ask you what is the unit of x. Then you have to say it is radian per second square. Next, alpha, what is the formula? It's very simple one. Now, whenever there is one car in a circular path, so there will be centripetal force. And how to calculate the centripetal force? mv square by r. Now, why the object is in circular path? Because of the static friction between the tires and the road. Now, it's very easy one to calculate the velocity, the maximum velocity at which if it travels, then it will be still in circular path. It's your what? This is your, you can use this formula if there is friction. So V is equal to square root mu R G. If the friction is 0, that means no friction is there. Then your velocity, what is the velocity? V is equal to square root R G. If it is beyond that one, so it will slip off. Next one. This is your textbook question. Example number 9.2. Please go through your textbook and find out. This is page number 264 and 271. So these are your questions once again, and this is your graphical question. First, step number 1, calculate the total time. So you can see here they have given different time intervals. So calculate all the time first. Then your delta theta. What is your angular displacement? So it is 7 times 7 revolution. So 7 into 1 revolution is 2 pi. So 7 into 2 pi is your theta. Omega initial is 0 and half alpha t square. So from here you calculate your alpha. It's very simple one, but very important one. Once you calculate alpha, then you just use the same alpha here. So omega is equal to omega 0 plus alpha t. Next, it is the same way. It is already worked out. Yeah, this is also very important one. This is your, when the object is in circular motion, how this alpha or your angular acceleration decides whether it is slowing down or it is still in circular path. Here you can see when alpha is greater than 0, so the object's angular velocity is increasing, and your total or the net acceleration is your above this radius, you can say. But when your alpha is 0, that means omega is your constant. Then what is happening? So the net acceleration is exactly towards the radius, drawn radius. Radius is everywhere. Now here at this point, the net acceleration is your downward when the object is having your negative angular acceleration. That means it is slowing down. Next, so these are your important question. Again, this is your Formula One racetrack. So the friction force is acting towards the center, and there are two forces. One is your weight, which is acting down, another one is your normal force, which is acting upward direction. So just to use the formula v is equal to square root mu rg, you can easily calculate the velocity of different cars. Next. So express the linear acceleration vector of an object as circular motion. So this is your linear acceleration of the object, which has two components. One is your tangential, another one is your radial. So acceleration centripetal towards the center, omega square r. So just to substitute, you will easily get the answer. Next one. Again. So this is your direct formula to calculate the centripetal acceleration of an object. I hope you remember the formula. So AC is equal to square root AT square plus AC square. Sorry, A total AT and AC. So just to substitute the value of AC and AT, then you will get your, so R is outside alpha square plus omega F to the power 4. You can remember this one or you can remember this one. Anyone? Then what is your theta? So tangential is your y component and this is your x component. If we just divide, you will get your theta. Next, this is one simple equation. It is given omega square equals omega 0 square plus 2 alpha delta theta. This one, 3600 RPM. So RPM means revolution per minute. So revolution in 1 minute. So in 1 minute, that means in 60 seconds, how many times it is revolving? 3600 times. So in 1 second, how many times it is rotating? 3600 divided by 60 times it is rotating. And one rotation is what? One rotation is your 2 pi radian. So in 1 second, how many times in angle it is happening? So 3600 divided by 60 multiply your 2 pi. The same thing they have given. This 600 2 pi divided by 60 and your theta initial is your 0. Now, here this is very interesting question. Which one is your correct diagram? So because the object is attached to the wall when it is rotating at very high speed. So how many forces are there? So there are three forces. One is your weight, another one is your friction force because the object is attached to the wall, so it is trying to fall down. So the friction force here, this is friction force, this is normal force, and this is your Fg, weight. So the A is your right answer. So this is the given diagram. And here, this is also very important question. If the speed is, if the radius of the loop is doubled, I think we solved this question in your classroom. So then what will happen? So V top, it will be square root 2 V top. And this is your very important diagram. Make sure you follow all the possibilities here. So the next question is here. So there are some extra questions also given, which is not there in your syllabus. It's okay if you practice it more. The tough one, you can just leave it, but rest of them, it is there. Next, again, so when the, so the question is, so the speed is, radius is given, how fast can the car be traveling to maintain a constant contact with the ground? Beyond that, it will fly off the road. So your FC centripetal force, they have two components, N plus mg, Fg. So, and here is your N is equal to 0. So Fc is mv squared by r, Fg is mg. So V is equal to square root g r. This is V equals 9.40. This question is 6.9. It is not there. It is there. You have to calculate the center of mass of this system. So again, if you just use your mass, what is the formula of mass here? What is density? Density is equal to mass divided by volume. So what is mass? So mass is equal to density multiply volume. Density is represented by rho, volume is represented by V. This is the same one. And what is your volume? Volume is your area into your length. So just multiply, then you will get your volume. So these are few additional questions also given. Make sure you practice each and every one before your exam. Yeah, this one you can directly remember this formula. So V max equals square root Rg. So if you remember correctly, V has actually three formulas: square root Rg without friction. V has another one formula, mu Rg with friction. Another one, it is your banking of the road. Banking of the road means when the road is curved, not flat. Again, this is the same formula. So definitely they are going to ask this question from this formula especially. So that's the end of this discussion. I will share the file. So you practice and all the best for your exam.